Himachal Pradesh Breweries Limited. Himachal Pradesh Breweries Limited. Himachal Pradesh Breweries Limited has two bottling plants. Has two bottling plants. Has two bottling plants. One at Solan. One at Solan. Solan. Solan is a beautiful city in Himachal Pradesh. Solan. And other at Mohan Nagar. And other at Mohan Nagar. Mohan Nagar is also one of the places in Himachal Pradesh. You can say these two are the cities in which their plants of Himachal Pradesh Breweries Limited are located. Each plant produces three drinks. Three drinks. Apple juice, mango juice, and orange juice. Apple juice, mango juice, orange juice. The number of the bottles produced per day are as follows. The number of bottles produced per day are as follows. Take the table. Solar has a capacity of manufacturing 1500 apple juice bottles, 3000 apple juice mango juice bottles, and 2000 orange juice bottles per day. So that's for your own number is 1500, 2000, and 5000 for apple, mango, and orange juices respectively. The plant capacity production of different juices per day. Done with the table? Take down next. A market survey indicates that market survey indicates that during the month of April, there will be a demand of during the month of the April there will be a demand of 20,000 bottles of apple juice, 20,000 bottles of apple juice, 40,000 bottles of mango juice, 40,000 bottles of mango juice, and 44,000 bottles of orange juice. 44,000 bottles of orange juice. Full stop. The operating cost per day. For plants at Solan and Mohan Nagar. The operating cost per day for plants at Solan and Mohan Nagar is rupees 600 and rupees 400 respectively. Is rupees 600 and rupees 400 respectively. full stop. For how many days each? For how many days each? How many days each? Planned to be run in April. Planned to be run in April. I'll be repeating the statement. For how many days each plants be run? It is not a plant. Plants be run in April. So as to minimize the production cost. So as to minimize the production cost while still meeting the market demand. While still meeting the market demand. Okay, I will repeating the numerical for you. Let's understand what is the numerical, and then you can solve it at home, saving out the objective functionality. Right. So what we have been given is that Himachal Pradesh Breweries Limited is a company which has two plants. One is located at Solan, and another is located at Mohan Nagar. Right. So the capacity per day capacity of generation or production of apple juice, mango juice, and orange juice is given to us, right? So plant at Solan is capable to produce 1,500, 3,000, and 2,000 bottles per day of apple, mango, and orange juice, respectively. And similarly, the Mohan Nagar plant is able to produce 1,500, 1,000, and 5,000 bottles per day of apple, mango, and orange juice, respectively. Right. So what they have told is that they have done some market survey, and in that market survey they have found that for the April month they have the demand of 20,000 bottles of apple juice, 40,000 bottles of mango juice, and 44,000 bottles of orange juice. So that is them according to the market survey. Now, to operate, one day operation cost of solar plant has been given to us, and that particular cost is ₹600, right? तो अगर एक दिन मुझे सोलर का प्लांट अगर कंटिन्यू चलाना पड़ेगा, एक दिन 24 घंटे के लिए, मुझे कितना पैसा लगता है? ₹600 लगता है. और वैसे अगर मुझे एक दिन का मोहन नगर का प्लांट अगर चलाना है, the operating cost or the production cost is coming out to be ₹400. So what they have to do is they have to decide कि सोलर वाला प्लांट कितना दिन चलाना चाहिए और मोहन नगर वाला प्लांट कितना दिन चलाना चाहिए, जिससे क्या हो जाएगा, उनका जो प्रोडक्शन कॉस्ट है या ऑपरेशनल कॉस्ट है वो कम हो जाए, प्लस उनका जो मार्केट डिमांड है वो भी सेटिस्फाई। तो ये क्या है, ये उनका प्रॉब्लम है, वो प्रॉब्लम को हमको क्या करना है, सॉल्व करना है विद द हेल्प ऑफ द ग्राफिकल मेथड. The very first step what we will be doing is the formulation of the problem. For the formulation of the problem, what we require is the framing out of the objective function and the constraints. Right now, well, we have a now very first step in deciding or starting with the problem formulation of the problem is we'll have to decide what are the variables. So we'll have to decide two variables. Let's say that we have two variables x1 and x2. So what is an x1 variable? What is the x1 variable and what is the description of your x2 variable? That is very very important. और वो कैसे करना है, मैंने लास्ट लेक्चर में बताया था आपका, उन लोगों ने हमको क्या बोला है, what is the for how many days each plants to be run. So we can tell that, we can see, we can हम लोग एक ये कर सकते हैं कि हमको कितना दिन चलाना है प्लांट को, ये हमको फाइंड आउट करना है. So what we can do is we can consider let x1 be the number of days for which this solar plant is working, and let x2 be the number of days for which Mohan Nagar plant is working. And bring the same thing, let x1 and x2 be the number of days for which plant and solar Okay, sorry. What we have done, we have declared the variables. Let x1 and x2 be the number of days for which the plant at solar to be run respectively. Now we have the operating cost per day of these plants. So rupees 600 is the operational cost. 600 per day is the operational cost for solar plant, and rupees 400 per day for Mohan Nagar plant. Right? And we have to minimize this operational cost. So what I can do is, if I'm running the plant for 1 day, if I'm running the solar plant for 1 day, it costs me rupees 600. If I'm running it for X1 days, how much it will be costing me? It will be costing me 600 X1. Similarly, if I'm running the Mohan Nagar plant for 1 day, I'm requiring the operational cost is rupees 400 per day. If I'm running it for X2 days, the cost will be how much? The cost will be 400 X2. What will be the total cost per day? It will be addition of these two. So this happens to be my objective function. Now this is the total operational cost, 600 x1 plus 400 x2. And what I have to do is I have to minimize this. So my objective function becomes minimize z is equal to 600 x1 plus 400 x2. Moving constraints regarding apple juice, mango juice, and orange juice. And what was that constraint? Right? What is the constraint? That in April month, the supply will be 20,000 for my apple juice, 40,000 for my orange juice, 40,000 for my mango juice, and 44,000 for orange juice. Now this is the constraint that I have. Okay. Now to frame out the constraint, they have given us the additional data that if the solar plant is working for 1 day, this much amounts of bottles of various juices can be manufactured, and if Mohan Nagar plant is working for 1 day, these much bottles of various juices can be manufactured. So let's only focus upon now apple juice. If I'm running the solar plant for 1 day, how many bottles of apple juice can I manufacture? I can manufacture 1500 bottles. And if I'm running that solar plant for X1 days, how many bottles will be getting manufactured? It will be 1500 X1. Okay. Similarly, if I'm running Mohan Nagar plant for 1 day, how many bottles are getting manufactured? 1500 bottles of apple juice are getting manufactured. If I run Mohan Nagar plant for X2 days, how many bottles will be getting manufactured? It will be 1500 X2. So what will be the total manufacturing of the bottle that can be completed with Mohan Nagar and solar plant? It will be the addition of these two terms, right? And for the April month, how much target we have or how much demand we have? It is 20,000. So we cannot produce 19,999 bottles. We have to produce at least 20,000 bottles, right? So my production should be more than 20,000 or equal to 20,000. It shouldn't be less than 20,000. So what inequality sign that we'll be using is that the production, the total production of apple juice should be more than 20,000. Should be more than or equal to 20,000. This production should be more than or equal to 20,000. Okay, I'm hoping that you have got this. Now this is the constraint regarding your apple juice, right? What is the constraint? Now let's frame out the constraint for your mango juice. Okay, so for mango juice, for solar plants, for the solar plant it produces 3,000 bottles per day. So for X1 days, it will be producing 3,000 into X1 bottles of mango juice, right? Similarly, my Mohan Nagar plant is manufacturing 1,000 bottles per day of mango juice, right? Now for X2 days, it will be producing 100 into X2. The total production of mango juice will be addition of this two terminology or addition of these two terms, and we have a demand for April month, and that is 40,000 bottles, right? So my production should be more than 40,000 bottles, or it should be equal to 40,000 bottles. Even a single bottle less than my 40,000 value is not accepted, right? So my constraint happens to be 40,000. Okay? Now, coming back to our constraints, there is the last constraint that we need to frame out, and that is regarding the orange juice, right? So, orange juice will require 44,000 bottles for April month, and per day production capacity at solar plant is 2,000 bottles. So, for X1 days, it will be 2,000 into X1. Similarly, for Mohannagar plant, it is 5,000 bottles per day. So for X2 days, it will be 5,000 into X2 bottles, and this should be always greater than or equal to 44,000 that we have got. Okay? So framing also, if we see what is the objective function and what is the constraint, so we'll have to write it in the better fashion. So framing of So if I write it properly, I have my it is the minimization function. Minimize z is equal to 600 x1 plus 400 x2. This is my objective function. My constraints are subject to. This is my first constraint, 1500 x1 plus 1500 x2 should be greater than or equal to 20,000. My second constraint is 3000 x1 plus 1000 x2 should be greater than or equal to 40,000. And my last constraint is 2000 x1 plus 5000 x2 should be greater than or equal to 44. So this is my constraint that I have got. Let's move towards our final constraint. Final constraint is that I cannot go in negative production. I can't produce minus 500 bottles, or I cannot produce like minus 1 bottle. So what will be my constraint? My x1 and x2 value should be non-negative. So final constraint is x1 greater than x1, comma x2 greater than or equal to 0. This is my constraint. Okay, so this is the objective function and this is the constraint that we have figured out, and now we can move ahead and we can solve this particular problem by yesterday's methodology, right? So what we'll be doing here, we'll be considering each constraint differently. We'll be finding out the constraint line for each constraint, and finally we'll be finding out what is the feasible region. Now after that, finding out the feasible region, we'll be finding out the optimal solution for that particular numerical, right? So let's proceed together. Our first constraint is neglecting inequality sign. Neglecting inequality sign in my first constraint. What I have is, what the equation that I get is 1500 x1 plus 1500 x2 should be equal to 20,000. Put x1 is equal to 0. Therefore, x2 comes out to be 20,000 divided by 1500, and the value comes out to be 13.33. So my first point becomes it is 0, 13.33. Similarly, if I move ahead, put x2 is equal to 0, x1 is equal to again 13.33 only. I get another point 13.33. This is with respect to my first constraint line. Similarly, I can move for the second constraint. You can repeat the statement here again. Right? For second constraint, neglecting the inequality sign, I have the equation as 3000 x1 plus 1000 x2 is is equal to 40,000. Is equal to 40,000. So what I will do is put x1 is equal to 0. Therefore x2 I get as x2 I get as 40, right? So I get a point at 0, 40. Similarly, if I put x2 is equal to 0, I get x1 value 40,000 divided by 3,000. It comes out to be 13.33. My next value, next point comes as 13.33, 0. Right? If I move ahead with my third constraint and neglect this inequality sign, what I'll be getting is 2000 x1 plus 5000 x2 is equal to 44,000. Right? Now, putting x1 is equal to 0, put x1 is equal to 0, and you will be getting x2 as how much? 44,000 divided by 5,000, and the value comes out to be 8.8. Filter 0, 8.8. Don't just copy the values, don't be a Xerox machine. I guess you all have your calculator and you will be putting all those values. I guess this is visible, right? Now, lastly, put x2 is equal to 0 and x1 value comes out to be 22. I get a point 22, 0. This is the last point that I get. Are the values visible? Yeah, you get these values for the equation. So this is my first constraint line, my second constraint line, and this is my third constraint line. And fourth constraint x1 and x2 greater than or equal to 0 has already been taken care. If we draw our first quadrant as this is my x1, this comes out of my x2. So when I'm taking the values in the first quadrant, naturally non-negativity of the resources is getting fulfilled. This criteria is getting fulfilled. Now, what is the maximum value of x1 that we have? X1 if we see is here it is 13.33, 13.33, it is 22. So the maximum value of x1 that we have is 22. So we will be proceeding in that particular fashion. So we'll be taking it as 10 here, 20, 30, 40. So this numerical is the graphical. This is the graphical, right? So we'll be drawing this on the quadrant. So because of my restriction here, I am drawing it on the board, right? But for the exams and for all the exams, you will be provided a graph paper, and the graph paper you'll be using to solve it. So better way use a graph paper if you're practicing, and even for your assignment question, the answers expected are on the graph paper. Otherwise, it will create a confusion. Okay, so for maximum x2 value that we have is 40, right? So again, here it's moving that direction. Then 20, 30, here I have a value 40. Let's plot my first line. It is 13, 0, 13.33. 0, 13.33. Somewhere here it will be in the middle, it will be 15. I'm manipulating this point to be here. It is 13.33. Right? Similarly, it is 13.33, 0. So here somewhere it will be 50. Let me take this as a particular point, and I can join these 2 points with the help of we have join this line. Now let's go with the sign. first constraint has an inequality sign of greater than or equal to. So greater than or equal to मतलब कौन सा डायरेक्शन में लेना है आपको? चलो, this line should have certain direction, right? So below या above which this to be taken. If it is less than or equal to, the portion below the line is to be taken into the consideration. But now I have inequality sign which is greater than or equal to. So what I have to do is that I have to take a region which is above this line. So here, this type of arrow will have to be drawn for this particular line. You can again and 13.33 comma 0. 0 comma 40 is this particular point and 13.33 comma 0 is this particular point. So what I can do is I can draw a line to these two. Okay. So I have got this second line which is for 0 comma 40 and 13.33 comma 0. Again here the inequality sign is greater than or equal to. So the region which is above this line is to be taken into consideration. I will be putting the arrows in this particular format. This particular line is to be taken into consideration. I have my highest point which is 0 comma 8.8 and 22 comma 0. So 0 comma 8.8. So somewhere near my 10 value it will be there. So let's take this particular point as 0 comma 8.8 and 22 comma 0. You have this particular point as 22 comma 0. I will join these two lines that I have. Okay. So that particular line and again inequality sign is greater than or equal to. Here the region above this line is to be taken into consideration. So if you see all these three lines, right? So let's name this line first now. This is my first line which was 1500 x1 plus 1500 x2 greater than or equal to 20. I have my second line 0 comma 40. This particular line as 3000 x1 plus 1000 x2 greater than or equal to 40. And lastly, I have my this third line, which is 2000 x1 plus 5000 x2 greater than or equal to 44. Okay. Now we have to identify the feasible region. Feasible region is that particular region which is satisfying all the constraints, right? So if I take this, if I take my first constraint line, this line, so the feasible region will be lying above this line. If I take my second constraint line, this line, the feasible region will be lying above this particular line. And even for my third constraint line, the region, the feasible region will be lying above the this third line, right? So this all the constraints are to be fulfilled, and if all these constraints are to be fulfilled, correct me if I'm wrong, I'm drawing feasible region. So it is satisfying all the criteria. But what is the difference between yesterday's numerical and today's numerical? If you see that, if you see the difference in your yesterday's numerical, it was a bounded physical region. Now I have specifically taken this numerical to make you aware that the physical region can be unbounded. Now, what is an unbounded physical region? You can see that for few of these sides there is a boundary, but for few of these sides there is a we don't have any boundary. So this visible region can extend up to infinity. Okay, and this is called as your unbounded physical region. Yesterday, if you see, our physical region was having a boundary at every side, but today that is not the case, right? So this is your unbounded physical region. You can write under the name unbounded physical region. It is unbounded physical region. Right? So I hope that you have understood this particular graphical representation of this region. Now, yesterday we have seen which approach, extrema point enumeration approach. According to the extrema point enumeration approach, let it be a maximization of problem or a minimization problem, your optimum values will always lie on one of the vortex, right? So for vortex, particularly we have how many vortex here? Let's say that this particular point A is the vortex point. This particular point is B point. This particular point, what I have here is C point, and there is infinite. There is no boundary here. So we have only 3 points, A, B, and C, and my minimum value will be lying what? My minimum value will be lying on any one of these 3 points. Yesterday I told you a shortcut as well. Okay, if it is a minimization problem, here the point which is nearest to your origin will be your optimum point, right? And for a maximization problem, a point which is farthest from your origin will be what? It will be your maximization point, right? So, but we are not going to rely on here. Shortcut. What we are going to do is we are going to test our we are going to find it with the help of the numerical values, right? If we move towards the numerical values, I'll be rubbing you of the right? So, which vortex do we have? We have the physical region is which one? Physical region. This is the region A, B, C. Right? So this is our physical region. And we have to find out the values of the coordinates of point A, B, and C. So the coordinates of A. What are the coordinates of A? Very easy. It is 0, 40. This is the coordinate of your A, right? Even the coordinate of C is very easy. C का coordinate क्या है? 20, 0. You shouldn't be making the mistake of writing the coordinate. Don't write the 0, 20. How it will get is x1 value, so it will be 20, 0. Here, if you have x1 value is 0, you have a value of x2. It will be 0, 40. So that is to be kept in mind. Otherwise, you will be losing the mark. So for finding out the B point, if you are using a graph paper, it will be very easy to find out the exact value of this particular point. Like even if you are using a graph paper, the best method is to particularly see which lines are getting intersected. Now, this particular B point is the intersection of this line with this line. So which two constraints are there? ये वाला constraint कौन सा है आपका? ये वाला constraint आपका I've given the nomenclature. First line. This is your second line. This is actually your third line. Right? 200 x1 plus 500 x2 greater than or equal to 44. So your two lines are getting intersected. ये वाला लाइन और आपका कौन सा वाला लाइन? ये वाला लाइन. ये वाला और ये वाला लाइन क्या हो रहा है? इंटरसेक्ट हो रहा है. इनको क्या करो? इनके इक्वेशंस को आप लोग सॉल्व कर सकते हैं. तो B point is intersection point of lines 3000 x1 plus 1000 x2 is equal to 20,000, and which is the last line, plus 2000 x1 plus 5000 x2 is equal to what is coming out to be 12. Yeah, that is right. It is 12 comma. Okay. Find out what are the functional values of A, B, and C. Okay. So Z and A. Firstly, what was our objective function? Objective function is minimize Z equal to 600 x1 plus 400 x2. So this is our objective function. So the value of Z and in a proper format, the objective function we have found out the values. So the value of Z at B is equal to Z minimum is equal to 8800. The solar plant should run for 12 days and Mohan Nagar plant should be run for 4 days. And what will happen if we are running this particular plant for these number of days? The value of the value of the operational cost will be minimum, and plus the demand will also get satisfied, right? So this is how this particular